Okay, I made an error of omission here earlier on this assignment, and so on this problem 43, or is it 42? On this problem 42 that we're doing here, and I want to kind of go over what. All right, let's just start from the very beginning. All right, I'm not going to redo the whole thing because I was spot on up to um, the very last thing on the last question. So I've got this bullet that travels all the way through here. All right, so we got this bullet coming, and it's got an initial velocity 1, and it's got a mass, so it's got a momentum here. And then I said, all right, now it pops out at this end, and then it's going to embed itself here. All right, and we had to find the velocity of this block is given of block 1. We know and all that stuff based on well, that was given, and so we can find the velocity of the bullet here. Then I had you use that to find the velocity of this block, and that's fine. But the kinetic energy that they're looking for, I forgot about this block here. Don't forget his kinetic energy. This block is now moving. All right, so here's at part 2. So this block also has a kinetic energy that's after, because it's got a velocity, constant velocity going this way, okay, of block 1, and the block bullet combo right here, this bullet lodged inside this block right here, mass 1 plus mass of block 2 times the final velocity that you computed, and then mass of block 1 times its velocity. This also has a kinetic energy. So you've got, this is equal to P1, P of block 1, and this is equal to the momentum of, which you're going to find, which is equal to the P, to the momentum of the bullet, little b, and the big block 1 combination. And then so you got to add those two kinetic energies. So add those two to get your kinetic energy final. Okay? I forgot about that. So so that's interesting. So you have to do that because I actually did the problem. I kept getting it wrong. That second part is starting to frustrate me. All I was doing was taking the kinetic energy of this compared to the kinetic energy of that. And your kinetic energy before, remember, is just the bullet before it hits anything. Okay? So that's all fine and good. So we're all good there. All right? That's great. All right. I want to make sure I didn't lose the page 1. Oh, yeah. I already talked about problem. All right. Now, 43 we're going to do in class. 43 we're going to set up in class. However, for problem 43, here's what I want you to do. For problem 43, look at page 183. So for problem 43, look at page 183 in your text. And it goes through, probably better than I can, how to do a problem with an elastic collision. Elastic collisions are a little bit trickier. One, elastic collisions, the kinetic energy before is equal to the kinetic energy after, which is cool. But it also gives you some extra equations. So the final velocity of 1 of the first mass is equal to m1 minus m2 over m1 plus m2. And these equations are kind of buried, times the initial velocity of 1. And v final of the second one is equal to, now this is when it's coming in and it's hitting something that's stationary. An elastic collision where the first object is stationary. If both objects are moving, the equations are a little bit different. And then we've got the velocity of the second one would be 2m1. And it's just a matter of putting these equations together. m1 plus m2 times v01. So it becomes, if you're given both masses, then that pretty much spits out for you what the final velocities are. All right, and the book goes through a nice explanation of that. All right, track 5.